This video is for section 1.3, describing quantitative data with numbers. So we will begin by sort of revisiting some of those measures of center that we discussed, which were mean and median. So the first one we're going to talk about right now is mean. And so mean we know is basically the average. In statistics, however, we say that the mean of a sample is represented by something that we call X bar. And so X bar looks literally like X with a bar over top of it. To find the mean, of course, you know how to find the average or the mean, and that just means that you sum up all the observation values and divide by the number of observations. So it's also important that you understand some shorthand notation that we have for mean, and that would be the X bar equals, this is sigma X sub I over N. And so this basically means the same thing as this. The sigma is a Greek letter that basically stands for add them all up. And when we talk about X sub I, the subscripts on the observations are just a way that you keep up with you keep the observations distinct, so you can tell this one was from the first observation, this one was from the second observation, and so on and so forth. So basically, if you had N being 5, so say you had 5 observations, then you could have X sub 1, you could have X sub 2, X sub 3, X sub 4, and X sub 5, but you couldn't go to X sub 6 because you don't have you only had N observations. It's also important that you keep in mind that the subscripts, the 1, 2, 3, 4, and 5, do not necessarily indicate order or any other special facts about the data, but it does kind of help us to keep them separate from each other. So an example for calculating mean, it says refer to the data on travel times to work for the sample of 15 North Carolinians. And so this gives you a stem plot. Remember that the left would be our stems and these would all be our leaves. And so what we could do is we could write down each piece of data that we have. And so the first one has a 5-minute travel to work. There are 4 people that have a 10-minute travel to work. There's one with a 12, one with a 15. Then we have 2 20-minute travels, 1 25-minute travel, 2 30-minute travels, 2 40-minute travels, and 1 that travels 60 minutes to work. So for A, it says find the travel time for all 15 workers. So we know that our N is going to be 15 because it tells us that here and here. And so what we need to do now is just basically find the average of that to find what X bar is. So remember, this is X bar. So to do that, you would just go to your regular calculator mode and you would just type in what we had. So we had 5 plus 10 plus 10 plus 10 plus 10 plus 12 plus 15 plus 2 20s, 25, 30, 30, 2 40s, and a 60. So altogether that gives us 337, but we need to divide that by the number of observations we had, which was 15, and we find out that our mean travel time to work is approximately 22 and a half minutes. All right, so in part B, it says calculate the mean again, this time excluding the person who reported a 60-minute travel time to work what do you notice? And so we are going to exclude the 60-minute travel time to work because 60 would be considered an outlier since it is 20 away from the next closest travel time that we have in our data set. So we would exclude 60. And so basically, if you think about it, we know that we were at 337. So let's do this. Let's say 337 subtract 60 because that 60 was part of the 337. And that gives us 277. And this time, let's divide it by 14 because we had 15 people to start with. So when we do that, we get approximately 19.8. So X bar is 19.8 for this one when we exclude the outlier. So basically what we can find out from that is if we take these two numbers and we subtract them from each other, we say 22.5 minus 19.8, we get 2.7. And so what that basically means is that that one particular observation raised the mean by 2.7 minutes. So you might say the outlier raised the mean by 2.7 minutes. So of course we do have some problems with mean. As a measure of center, mean is sensitive to the influences of extreme observations or outliers, like we saw in this last example. So we could see that whenever we took the mean for all 15 workers, we found that our mean was 22.5, but whenever we left out that outlier, which was 60, our mean went down to 19.8. So we can see that the mean affected our or the outlier affected our mean by 2.7 minutes. So it made it seem a lot higher than it actually was because that number skewed the data so much. So basically, if our data contains any outliers, then mean is not a good measure of center for that data. So you basically have to choose between mean and median, and if you see that you have an outlier, it's probably not good to go with the mean to choose your center, to find your center. A better term for mean may be the fair share or the balancing point, and we're going to do an activity in class that kind of emphasizes this balancing point idea. Basically, the mean tells us how large each observation in the data set would be if the total were split equally among the distributions. Another way we can measure center is the median. And so the definition for median is the midpoint of a distribution or the numbers such that half the observations are smaller and the other half are larger. So the steps for finding the median are first to arrange all the observations in order of size from the smallest to the largest. That's going to be important because you are trying to find basically the data point that is directly in the center. And so if the number of observations n is odd, the median, which we call m, is the center observation in the ordered list. If the number of observations n is even, the median m is the average of the two center observations in the ordered list. So basically, if we had an n that was equal to 5, then we could say, okay, we have these 5 things here. And we would say, okay, if we split it right here and we let this one be the median, then that means we have 2 on the left and 2 on the right. Let's say that we had an even number, so we have 1, 2, 3, 4, 5, 6, and we are trying to find the median. Then what we would do is we would say, okay, the 2 in the center would be 3 and 4, so we would add together 3 plus 4 and divide it by 2. So we would have 7 over 2, or 3.5 as our median for this set of data. So going back to our example earlier of the travel times to work in North Carolina, we can find the median with this data set. We have 15 North Carolina workers, and everything is already ordered from least to greatest. So what we would do is we would say, okay, if we have 15 in the center of 15, we would basically take our eighth point and we would let that be our median, because we would have 7 on one side and 7 on the other side. So if I say that I'm trying to find my eighth point, I would say 1, 2, 3, 4, 5, 6, 7, 8. 20 would be my median, because I would have 7 on one side and then 1, 2, 3, 4, 5, 6, 7 on the other side. So my median travel time would be 20. The next example is finding the median when n is even. So the last example, we had 15 workers, which meant our median was odd. So we were basically trying to find that point that was directly in the center, that split my data to where I had the same number of observations on the left as I did on the right. But whenever we are even, we can't exactly do that. Because we don't have that odd number in the middle that would kind of allow us to have an even number on the left and an even number on the right. So the first thing that we are going to do is to make a stem plot for this one, for part A. So it says people say that it takes a long time to get to work in New York State due to the heavy travel or traffic near big cities. What do the data say? Here are the travel times in minutes of 20 randomly chosen New York workers. All right, so the first thing I should do is make a stem plot. So I see that I have 2-digit numbers except for my single digit 5. So what I'm going to do is I'm going to let one of my stems be 0, and then I'm going to have a stem for my teens, a stem for my 20s, a stem for my 30s, a stem for my 40s, 50s, and 60s. Let's do 70 and 80, because I see that my biggest travel time is 85 minutes. Okay, so there's my stems. My leaves are going to be my ones digits. So I know that 5 is going to go over here. I know I'm going to have 1 10, there's another 10, so 2 10s. There's a 15, so there's a 5. There's another 5, and another 5, and another 5. In my 20s, I know I have a 20. I have another 20. I have another 20. And I have a 25. In my 30s, I have 2 30s. In my 40s, I have 2 40s and a 45. Doesn't appear that I have any 50s, but I do have 2 60s and a 65. And then I don't have any 70s, but I do have an 85. And part B asks us to find and interpret the median. So what I'm going to do is I'm going to say, okay, I have 20 randomly chosen New York workers. So I'm going to find the 2 points that are in the middle. So if I have 20, I can make it to where I had, let's split it in half. So let's find 10 on each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so this would be the split right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so what I'm going to do then is I would take, my median is going to be in between 20 and 25. So I hope everybody is clear on that. So remember that each one of our stems matches up with a leaf, and so this would be 20, because 2 and 0 would make 20. And then my next leaf would be 25. So plus 25, and then I'm going to divide it by 2. 20 plus 25 would give me 45 divided by 2. And so you could say 45 divided by 2 gives me 22 and a half. So I could find out that my median is 22 and a half minutes. Also, just for sake of notation, median we represent as a capital M. Comparing the mean and the median. The mean and the median of a roughly symmetric distribution are close together. If the distribution is exactly symmetric, the mean and the median are exactly the same. In a skewed distribution, the mean is usually farther out in the long tail than is the median. So why would we use the median? Unlike the mean, which is influenced heavily by outliers, the median is unaffected by outliers due to the fact that outliers do not change the value of the middle term in the data set. For example, if you see in this data set, you have 1, 2, 3, 4, 4, 5, 6, 7, 7, 7, 8, 8, 9. And so what we would do on this one, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, because we have 13, then that means that our median would just be the one that's in the middle. So we would make sure that we had 6 on each side, and that one would be our median. If we were to find the mean for this set, it tells us that the mean is 5.6. The same data set with one small change, so that would be changing our observation of 9 to 40, would make the median still stay 6, because the only thing I did change was I still had 13, but I changed my last one to be 40, but the number in the middle did not change, but it did change my mean to 7.9. So you could say 7.9 minus 5.6 and see that you had a change of 2.3 because you had that outlier of 40. For this check your understanding, you are going to refer to the following setting for questions 1 through 4. So here, once again, is the stem plot of travel times to work for 20 randomly selected New Yorkers. Earlier, we found that the median was 22.5. So number 1, based on the stem plot, would you expect the mean travel time to be less than, about the same as, or larger than the median, and why? So in number 1, the first thing that you have to look at is basically the shape of the distribution. And so you can kind of follow just by how this is written, you can kind of follow and see what the shape would be. So the shape would be something similar to this. And so because this particular data set is obviously skewed right because we've got this long right tail, then we would expect the mean to be greater than the median, because remember that that outlier, 85, is really going to affect what the mean is. So the mean is going to be greater than the median because the data is skewed right. For number 2, use your calculator to find the mean travel time. Was your answer to question 1 correct? Okay, so for number 2, what you would do is you would go to your calculator and you would type in each one of your stems and leaves. So 5 plus 10, 10. Let's see, you've got 4/15. You have 3/20. You have a 25. You have 2/30. Two 40s, a 45, 2 60s, a 65, and an 85. And then you're going to divide that by how many that you actually have, which is 20 randomly selected New Yorkers. So whenever you do that, you get that the mean is approximately 31.25. So, as you can tell, the mean is 31 and a quarter, and the median was 22 and a half. So, our answer to question 1 was correct. And 3, interpret your result from question 2 in context without using the words mean or average. All right, so the way that you would interpret your result from question 2 without using mean or average is you would say, if we divided the travel time evenly among all 20 people, each would have a 31 and a quarter minute travel time. Question 4 says, would the mean or the median be a more appropriate summary of the center of this distribution of drive times? Justify your answer. All right, so if we look at the data, what we see is that 85 is an outlier. So because 85 is an outlier, we would use median as a measurement of center for this one. And so you might want to include something about the data being skewed right. Measuring spread. So we've talked about spread and what it is, and so we've talked about how spread is basically the range from the least observation to the greatest observation. And so what we're going to do now is talk about the interquartile range, or what we call IQR. So far, our only description of spread came from the simple context of range. What is this? This should be our... Come on, Mr. Hopper. So our only description of spread came from the simple context of range. However, we can extend that through the use of the interquartile range. And so whenever we do the interquartile range, you will have a Q1 and a Q3. Your Q1 is the value lying 1/4 of the way through the data. The Q3 is the value lying 3/4 of the way through the data. And the definition for the interquartile range of the IQR is the 50% range of data between the first and the third quartiles. So this may seem a little foreign to you right now, but it will make more sense whenever you see a numerical example. So how do you calculate the quartiles Q1 and Q3 and the interquartile range? So your first step is to arrange the observations in increasing order and locate the median in the ordered list of the observations. So we already know what it means to arrange them in increasing order. We've already talked about how you can find the median. So step 1 should be fairly simple. For number 2, it says the first quartile is the median of the observations whose position in the ordered list is to the left of the median. The third quartile is the median of the observations whose position in the ordered list is to the right of the median. And the interquartile range, IQR, is defined as Q3 minus Q1. So basically, in order to find the IQR, you're going to have to find Q3, which is the third step, and Q1, which is the second step, and subtract Q1 from Q3 to get the IQR. Again, hold off until you make your judgments about this until you see a numerical example like this one. All right, so in an earlier example, we looked at data on travel times to work for 20 randomly selected New Yorkers. Here is the STEM plot once again. And so our goal now is to find and interpret the interquartile range, or the IQR. All right, so we have just talked about our steps for finding the interquartile range. So the first step is to put all of our data in order from the least to the greatest. Okay, so looking at our STEM plot, we have 5, we have 2 10s, we have 4 15s, we have 3 20s, 25, 2 30s, 40, another 40, a 45, a 60. Oh, I really wanted to make this all fit. Okay, hold on. All right, so now we have this little extra awkward space over here, but I'm going to deal with it. Okay, so the first step is to find the median. Well, our first step is to organize, and then once we organize, then we're going to find our median. Okay, so we said we had 20 randomly selected workers, which means that we want to find the one that is directly in the center of that. Okay, we want to find the 2 that are in the middle, and then we're going to find the average of those 2, and that would be our median. Okay, so I'm going to say, I'm going to find where my 10th one is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason that I found my 10th one is because I would have 10 on this side also, because I have 20, so divided by 2, and that would mean that my median would be directly here in the center between 20 and 25. So the way I find the median, again, is by saying 20 plus 25 divided by 2, which we said earlier was 45 divided by 2, which we said was 22.5. So my median would be 22.5. All right, so then to find the Q1, what you're going to do is you're going to say, okay, I know my median is here. And so now I know I've got 10 on this side and 10 on that side. So I'm going to go and I'm going to split this part in half, and I'm going to split that part in half. So I'm going to find my 5th one. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So we did it right. And this would be my Q1. So my Q1 would be 15. And technically what you would do is you would say 15 plus 15, which gives you 30, divide by 2, and that would give you 15. And the reason I would do that is because I have 10, so it would be kind of like what I did here to find the median. I want to find the one that's directly in the center, but I would have to find the average of these 2, which turns out to be 15. Okay, so same thing on the other side to find my Q3. So I'm going to count over 5, and that will be where I split it, and I may have to find an average. So 1, 2, 3, 4, 5, split right there, and that would be where my Q3 is. And I would have to say for this one, Q3 is going to be equal to 40 plus 45 divided by 2. 40 plus 45 would be 85. And divide that by 2. And 85 divided by 2 would be 42.5. So my Q3 is equal to 42.5. All right, to find my IQR, my formula for that is to say Q3 minus Q1. So I already know that Q3 is 42.5, and I know that Q1 is 15. So whenever I subtract those, I get 27.5. And that would be 27.5 minutes because our information is all about minutes. All right, so what does the interquartile range actually mean? And so what does it mean in particular in this context? And so what you basically have is The range of the middle half of the travel times for New Yorkers in the sample is 27.5 minutes. So the range of the middle half of the travel times is 27.5. Identifying outliers. So we've talked about outliers. We know what they kind of are, but we kind of use like common sense to identify outliers. There is a useful formula though that we can use to identify outliers, and that is the IQR outlier rule. Basically what that means is an observation is considered an outlier if it falls more than 1.5 times the IQR above the third quartile or 1.5 times the IQR below the first quartile. So remember, you can have an outlier on the left side of the data or on the right side of the data. And so one that is 1.5 IQR above the third quartile would be on the right side, and 1.5 IQR below the first quartile would be on the left side. So on this example, we are going to identify outliers. So earlier we noted the influence of one long travel time of 60 minutes in our sample of 15 North Carolina workers, and now we're going to determine whether this value is an outlier. So the first thing we need to do is we've got to find our IQR. So we're going to take this data set and we're going to organize it so it goes highest to lowest. So we've got 5, we have 4 10s, we have a 12, we have a 15, we have 2 20s, we have a 25, we have a 30, another 30, a 40, and a 60. And first thing we need to do is find our median. So we had 15. That means that because it's an odd number of observations, we should be able to find the 8th one, and that one should be our median. So 1, 2, 3, 4, 5, 6, 7, 8. 20 is our median. And so from there, what we're going to do is take this part and find the middle of it and find the middle of this part also, and that would be my Q1 and my Q3. So I'm going to say, okay, there were 7 on this side, so that basically means that I need to find the 4th one, and that's going to be my Q1. So 1, 2, 3, 4, Q1. And so as you can tell, there's 3 on this side and 3 on that side. So I'm going to do the same thing over here. So I know that there's 7 over here. I'm going to find the 4th one, and that should be my Q3. So 1, 2, 3, 4, Q3. So again, 3 on the left, 3 on the right. All right, so I need to find my IQR. To find my IQR, I'm going to say Q3 minus Q1. So I know that Q3 is 30. I'm going to subtract Q1, which is 10, and that gives me an IQR of 20. All right, so now I'm going to check and see if this 60 is an outlier. I kind of have an idea that it is, but I want to do the formal for sure, is this an outlier? So what I'm going to do now is I'm going to say, okay, 1.5 times 20. Now the reason I'm doing 1.5 times 20 is because this is my 1.5 outlier rule. So if I do 1.5 times 20, that gives me 30. All right, so now that I've calculated my IQR rule, what I'm going to say is I'm going to say, okay, I'm going to take my Q3, which was 30, and if I add to it 30, which was my IQR rule, then I would get 60. So what that would mean is any value that's greater than 60 would be considered an outlier. Because 60 was included, but obviously 60 is not greater than 60, then it's actually not considered an outlier. Even though it kind of appears like it might be because it's kind of far away. Now you could also go in the other direction. And so if you go in the other direction though, instead of adding to the Q3 like we did here, what we would do is we would take our IQR take our Q1, which was 10, and we would subtract out 30. And if we subtracted out 30, we would get negative 20. Now, obviously, no one has a travel time of negative 20, so this is kind of irrelevant. But that is one way to find an outlier on basically the left side of the median. All right, the 5-number summary of a distribution consists of the smallest observation, the first quartile, the median, the third quartile, and the largest observation, and it's written in order from smallest to largest. Symbolically, the 5-number, number summary appears as minimum, Q1, median, Q3, maximum. Graphically displaying the 5-number summary, we would use a box plot. So a central box is drawn from the first quartile Q1 to the third quartile Q3. A line in the box marks the median. Lines called whiskers extend from the box out to the smallest and the largest observations that are not outliers. So a box plot is what you probably learned originally as a box and whisker plot. And so sometimes you will hear me refer to both of them. They mean the same thing. So making a box plot. Barry Bonds set the major league record by hitting 73 home runs in a single season in 2001. On August 7th, 2007, Bonds hit his 756th career home run, which broke Hank Aaron's long-standing record of 755. By the end of the 2007 season, when Bonds retired, he had increased the total to 762. Here are the data on the number of home runs that Bonds hit in each of his 21 complete seasons. So the first thing we have to do, what it's asking us to do, is make a box plot. So what we need to do first is take our data and we want to organize it so that it goes least to greatest. So as I'm kind of scrolling through here and kind of checking things out, I see that 16 is my least. So I've taken care of 16. It appears like next I would have 19. Next I would have 24. I have two 25s. After 25, I'd have 26, quite naturally. 28 would come after 26. Then it appears that I would go with 33. And I would have two of those. 34 would come after 33. There's another 34. Then I would have 37. And there were two 37s. 40. 42. Y'all, it's going to drive me insane if I can't fit these off. 45. Two of those. 46 two times. It's going to happen. I'm going to make it happen. 49 and 73. So the first thing I have to do is I have to find my median. Because I have an odd number of observations, I basically have to find, think about it as being 10 on one side, 10 on the other side, and 1 in the middle. So I need to find my 11th one. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my median then would be 34. So I can check it and make sure that I have also 10 on this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 on each side, which means 34 is my median. All right, then I need to find my Q1. So to find my Q1, I'm going to say, okay, I have 10 on this side, which means that I'm going to find the 2 that are in the middle and find the average of them. So I'm going to say 1, 2, 3, 4, 5, and 25 and 26 would be my 2 that are in the middle, because I would have 1, 2, 3, 4 on this side, 1, 2, 3, 4 on that side. So I would have to find the average of 25 and 26, which we know is 25.5. So Q1 is equal to 25.5. I would do the same thing on the right side so that I can get my Q3. And so what I would do is I would say, okay, there's 10 over here. I'm going to find my 5th one, and the one beside that is going to be my fifth. Basically, my 5th and my 6th are going to be my where I find my median, or where I find the median of that part. So I would say 1, 2, 3, 4, 5, and 6. So then I have 4 on this side and 4 on that side, and the Q3, because they're 45, 45, that would make 90 divided by 2 would be 45. All right, I also have to have my minimum. My minimum would be my smallest number, which in this case would be 16, and my maximum, which in this case would be 73. So now I have, this is also my median. So I have my minimum, my Q1, my median, my Q3, and my maximum, which make up my 5-number summary. So I need to also see if I have any outliers. So to check my outliers, I'm going to say, okay, I know that I've got to find my IQR. So I'm going to find my IQR by saying 45, which is Q3, minus 25.5, which is Q1. And so if I do that, I get 19.5. So I'm going to use that and my 1.5 IQR rule to see if I have any outliers. So I'm going to say 1.5 times 19.5, and that would be, so 1.5 times 19.5 gives me 29.25. So then I'm going to say, okay, if I have any outliers on the right side, that would be 45 plus 29.25, which would give us 74.25. So if I have anything that's over 74.25, then it's out. Or it's not out, it's just considered an outlier. So my maximum is 73, which means I'm good on that side. So then I do the other way, and I say Q1, which is 25.5, and I subtract out 29.25, and that would give me a negative number. It would give me negative 3.75. And so obviously I can't have negative 3.75 hits in baseball. So I definitely don't have any outliers on that side. Okay, so I've done my 5-number summary, and I've checked for any outliers. So now I'm going to make my box and whisker plot, or my box plot. So the way that I do that is I'm going to say, I'm going to draw a number line. Hey, look at my straight line. And I'm going to label it. So I have 15. And let's do it by 5. So I'm going to say 15, 20, 25, 30, 35, 40, 45, and I need to make sure that I go to 75. Okay, so now I'm going to start by marking my Q1 and my Q3, which is going to be my box. So my Q1 is at 25.55, so a little bit of my box on that side. And my Q3 is at 45, so I go to 45 and I make that. Okay, so there is my box. There we go. Did you see how you liked how I fixed that? All right, so now you're going to go find your median, which is at 34. So it's close to 35, and that would be your median. So there's my median, there's my Q1, there's my Q3, and then I also have to include my maximum and my minimum. So my minimum is at 16, so just a little bit further than 15, and you put a dot and a line. Or some people like to put a line and a line. So let's go with a line and a line just because that is what your that's what the book does. And so then let's also do 73 because we said that 73 was our maximum. So I'm going to go past 70, not quite to 75, somewhere right in here, and put my line and then a hole. Woo! There we go. So that is my minimum, and that is my maximum. And if you want to, you can label them so you know what's going on. So we might say that this is 25.5. We would say that this was 34. This is 45. We know that this is 73. And we know that this is 16. Of course, there's directions for how you can make your own box plot on your calculator. So let's start by, you could start by like using the travel time data for North Carolina in L1 and for New York in L2, and then make a two statistics plot 1 to show a box plot of North Carolina and plot 2 to show a box plot of New York. And so what you need to do is make sure that you turn both of those plots on, and so the directions for that are here. And then you can kind of compare them from there. Feel free to, if you have a calculator at home, to try this. You can also try this anytime that we're in class, and if you would like me to go over this when we are in class, I would be happy to do that. Better measures of spread. So we talked about what spread is, and so spread is basically your range. And so better measures of spread would be standard deviation and variance. Your standard deviation measures the average distance from the observations from their mean. It is calculated by finding an average of the squared distances and then taking the square root, and symbolically we say S sub x. And so if you see S sub x, that really means standard deviation. Variance is the average squared distance from the observations to the mean. In general, it is the square of the standard deviation. And so this is your fancy mathematical notation for that. So the first thing we will talk about with the better measures of spread is how to find standard deviation. So the first thing you do for standard deviation is you find the distance of each observation from the mean and square each of these distances. Step 2 is average the distances by dividing their sum by n minus 1. The standard deviation, S sub x, is the square root of their average squared distance. More important than the details of calculating standard deviation are the properties that determine the usefulness of the standard deviation. So standard deviation measures spread about the mean and should be used only when mean is chosen as the measure of center. So you can't find standard deviation from the median. Standard deviation is always greater than or equal to 0. So standard deviation equal to 0 only when there is no variability. This happens only when all observations have the same value. Otherwise, standard deviation is greater than 0. As the observations become more spread out about their mean, standard deviation gets larger. Standard deviation has the same units of measurement as the original observations. For example, if you measure the metabolic rates in calories, both the mean x bar and the standard deviation S sub x are also in calories. This is one reason to prefer standard deviation to variance, which is S sub x squared, which is in squared calories. Like the mean, x bar, standard deviation is not resistant. A few outliers can make standard deviation very large. So, for this check your understanding, this is not going to be one that you are going to have to answer questions about. We're just going to go over this because we haven't practiced any standard deviation or variance yet. So the first thing we have to do is find and interpret the mean. So to find the mean, you just find the average. So you're going to take each of these numbers and add them together. So 67 plus 72 plus 76 plus 76 plus 84. And then you are going to divide it by the number of observations that we have, which is 5. So 67 plus 72 plus 76 plus 76 plus 84 gives us 375. We take 375 and we divide it by 5 and we get our mean is 75. For number 2, it says make a table that shows for each value its deviation from the mean and its squared deviation from the mean. So what we would do is we would basically say we would make a column for our observations, and then we would make a column for our deviation, and we would make a column for our squared deviation. And so keep in mind that this is your deviation, this is your deviation squared, this is our standard deviation, this is our variance. So you might want to label that. Okay, so our observations were 67, 72, 76, 76, and 84. So to find our standard deviation, what we do is we take our observation and we subtract it from the mean. So 67 minus 75 gives us negative 8. Then we do 72 minus 75, which gives us negative 3. Then we do 76 minus 75 to get 1. Another 76 minus 75 to get 1. And 84 minus 75 to get 9. To get our standard, our squared deviation or our variance, what we would do is we would say, okay, our standard deviation for 67 was negative 8, so squared would be 64. Our standard deviation for 72 was negative 3, so our variance would then be 9. Our standard deviation for 76 was 1, so our variance would be 1. And the same thing for this one. And our standard deviation for 84 was 9, so our variance would be 81. 3 asks us to show how to calculate the variance and standard deviation from the values in our table. And so basically what that means is you would, in the variance column, it would be the sum of the square deviations taken from the total row divided by 4, the number of observations minus 1. In this case, that would mean 156, because that would mean we added together 64 plus 9 plus 1 plus 1 plus 81, and that would give us a total of 156. And we would divide that by 4. The reason that we choose 4 is because our observations was 5, and so we always, whenever we are calculating variance and standard deviation from the values in the table, what we would do is we would say 156, which is our variance, divided by n minus 1. And so that would be 156 divided by 5 minus 1, or 156 divided by 4, which gives us 39 inches squared. Our standard deviation for this entire set of data would be to find the square root of the variance. So the square root of 39, which would be 6.24 inches. So 4 says interpret the meaning of the standard deviation in this setting. So the standard deviation for everything was 6.24 inches. And so what that means is the player's height vary 6.24 inches from the mean height of 75, which is the answer that we got in 1. And this is just basically on average. So, of course, the good thing about having all this technology at your fingertips is that you can always find this information using your calculator as well. And so if we went back to our example about the North Carolina travel times and the New York travel times, we could find our mean, our standard deviation, our variance, and all of that by using the calculator. I'd be happy to go over these in class if you'd like. Choosing measures of center and spread. So the median and the IQR are usually better than the mean and the standard deviation for describing a skewed distribution or a distribution with strong outliers. So we use X bar and standard deviation only for reasonably symmetric distributions that don't have outliers. So you use median and IQR if you have something that is skewed or that has outliers. So median and IQR for skewed or something with outliers, strong outliers. And then you use X bar, which is the mean, and S sub X, which is the standard deviation, for symmetric distributions. All right, so here's an example. For their final project, a group of AP statistics students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period. Here are their data. And so you see the males and you see the females. What conclusions should the students draw? Give appropriate evidence to support your answer. All right, so what we have to do for this one is basically to complete the 4 steps that we talked about in a couple of videos back. So the first thing we have to do is we have to state our question. So our question is, do the data give convincing evidence that females text more than males? So if we are having to tell whether the data give convincing evidence that females text more than males, then we need to plan how we plan to do that, or how we're going to do that. And so basically what we are doing is we are comparing females to males. And so one way that may be easy to do that is to do a side-by-side box plot, because then we could see all the information that we needed about females and all the information that we needed about males and make our conclusions from that. So the first thing you want to do is make a side-by-side box plot. And to calculate all of those things that we've talked about in this video. So that would be your mean and your standard deviation and your 5-number summary. Remember that your 5-number summary would be your minimum, your Q1, your median, your Q3, and your maximum, and then also to calculate your IQR. And once you get all that done, then you might want to compare the shape, the center, spread, and outliers for both distributions. All right, so once you have stated your question, you have made a plan for how you're going to figure it out, then you need to actually do your plan. So here is what we can do. We can go to your calculator, and we can put all of this information in for L1 and L2. So start by going to Stat, go to Edit. For L1, let's make this all the males. So if you've got anything in L1, you can bump yourself up using the up arrow to L1, hit clear, and that clears everything out of L1. So let's put the males in there for L1. So we're going to say 127 and 44 and 28, 83, 0, 6, 78, 6, 5, 213, 73, 20, 214, 28, and 11. Then you need to do your females in L2. So 112, 203, 102, 54, 379, 305, 179, 24, 127, 65, 41, 27, 298, 6, 130, and 0. Going back to your calculator steps, once you get everything plugged in L1 and L2, you're going to go to Stat, you're going to go to Calc. One variable statistics will give you everything that you need for this. L1 is the list that you're going to do. Frequency list, you don't have to worry about. Hit enter on calculate. What we calculated was males. So for males, and the reason I say that we did that for males is because we used L1. All right, so for males, you had, do this. You had a mean of 62.4. You had a standard deviation for 71.37. And those are really the only two things that we want from what we did on our calculator. The other things we would get from doing our IQR and our median and all that stuff. So I'm going to give you that information. Feel free to go back and check me, make sure that you understand how to do all of that. But your minimum for the males would be 0. Your Q1 for the males would be 6. Your median for the males would be 28. Q3 would be 83. Your max is 214. And your IQR is 77. For females, this time you can go back to your calculator to get your mean and your standard deviation. And so you go to Stats, you go to Calc, you go to one variable statistics. This time for list, we're going to change it to L2. So you can do second 2, gets you L2. Go to calculate, and calculate will give you that your mean is 128.3. It also gives you your standard deviation at 116. I'm going to give you your 5-number summary and your IQR. So your 5-number summary would include your minimum, which for females would be 0, your Q1, which would be 34, your median, which would be 107, your Q3, which would be 191, and your maximum, which would be 379. Your IQR would be 157. One thing we did not do is to calculate any outliers that we might have in the males and in the females. So remember, you use your 1.5 IQR rule for that. And so for males, I'm going to kind of go over here to the side. For males, your IQR rule would look like 1.5 times 77. which would be 115.5. All right, so you would say, okay, my Q3 is 83, so 83 plus my 115.5. Would give me 198.5. So anything that's over 198.5 would be an outlier. So if I'm looking through here, 213 would be an outlier, and 214 would also be an outlier. My Q1 was 6. Obviously, if I do Q1 minus my 115.5, it's going to give me something that's negative, and I can't have negative text messages, so that's kind of irrelevant to try to find an outlier to the left side. So then I could try my females and see if I had any outliers there. So to find out if I have any outliers for the females, I have to use my IQR rule, which would be 1.5 times my IQR, which is 157. So 1.5 times 157 would give me 235.5. So 235.5 would be my what I would use to find if I had any outliers. So I would use my Q3 for females, which is 191, and say 191 plus 235.5, anything over that would be considered an outlier. So if I said 191 plus 235.5, that gives me 426.5. And so 426.5 would be the place where if I had anything bigger than that, it would be considered an outlier. So I actually don't have any numbers in my females that are considered outliers. I could go the other way. If I go the other way, though, I would say 34 minus 235.5, which is obviously going to give me a very negative number, and I can't have very negative number text messages. So on the females, I have no outliers. On the males, I have 2 outliers. So then I would want to construct a box plot. So the way I could do that is I could go to my calculator. And I've already plugged everything in for L1 and L2. So what I would have to do now is I would go to second Y, because that's my stat plot. Make sure that stat plot 1 is on and that stat plot 2 is on. And I also want to adjust those so that I have a box plot. So I'm going to scroll down to type, and I'm going to change them both to a box plot. So then I need to go back and I need to fix plot 1. So that one's on. I need to turn this to a box plot. So once I do that, I'm going to hit graph. And I may need to change my window so I can go to zoom 9, zoom stat, and that would give me a good picture. So what I see there is I can tell everything that I need to know from that. It's kind of hard to see, obviously, because it's zoomed out so much. But right here where you see these 2 dots, the reason that you see, or this 1 dot, what you are really having there is 2 dots that are really, really close, because our outliers, remember, were 213 and 214, and so those are obviously very close. But this is essentially what you would see. Actually, let's go back 1 second. I think we have a problem. I think we have both of them showing us L1. We do. So let's change this X list here to L2 by doing second 2 to see L2 and then graph it. There we go. So we see a much better picture now, and we can hit zoom stat now and see both of those. So that can kind of show you where your medians are, where your Q1s are, where your Q2s are, or Q3s are, and any outliers that you see. It also shows you, obviously on this one, you have such a wide spread. All right, so the last part is to conclude. So for do, I'm not really going to write anything down because we kind of saw that all in the pictures on our calculator. So for conclude, and you can always go back and sketch those from what I just had in the video. So for conclude, you would say the data from this survey project give very strong evidence to support the students' belief that females text more than males. So the data shows, or let's say the data gives strong evidence. That's actually probably a better way to say that. So the data gives strong evidence that females text more than males. And then you could go on to give some actual numbers. So you could say females sent and received a median of 107 texts, and we have that up here in our information, over a 2-day period. Which exceeded the number of texts reported by over 75% of the males. Ta-da, we're done.